Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem number 3 LeetCode, longest substring without repeating characters. So the problem statement says that given a string S, find the length of longest substring without duplicate characters. So we have to just find the longest substring in the string which we are given, and where we in the substring we do not have any duplicate characters, so we have to just find the longest substring there. For example, the string is given abc ab cbb. Now here we can see that the longest substring which we can get is either this abc, because after this we will just include this a and we will have duplicate characters. But here in abc the longest substring is, the substring size is here 3, and another we can see this bca, and another this cab, another we can see, yes, just this only. So longest substring which we can find here is abc, which doesn't contain any duplicate character. So similarly here also we can just find b, which which is having the length of 1, and here we can find pw wkew, so we can find this substring wke, so it's having the length 3. Alright, so how can we find this? How we can find? So first of all, the brute force approach which can come into my mind is to just check all the substring, take it out, and just check if in any substring there is no duplicate character, and just we'll just increase the count if there is no duplicate character. But this will take very high time complexity for checking all the substring and then just counting. Alright, now what's the better approach or optimal approach we can think of it? We can just use, the question is, this question is like that subarray sum equals to k. In the subarray we have to find the any sum. In that question, the question is similar to this. So here we are just given string, so here this subarray is known as substring. So we'll here also use an ordered map, or we can just use normal map, or an ordered set we can use. So I will tell you how. So we can use this example abc pb, a b c a b c b b, if I'm not wrong, abc abc bb. And from here what we can do, we can just create a map, and suppose we are here now, and we move, and we have got a new element as a. First of all, let's create an subarray. Here our subarray is initially empty. Alright, and now we have found a, so we will check is there any a in our current string or not. So there is no a. For how we can check if a is existing in our current substring or not? We can just store a map, and we can just keep count of all the uh, characters which you are getting. So if count of a is 0, or it doesn't exist in the map or an ordered set, or also we can use frequency array also. All right, so I'm here using map, an ordered map, and if I'm on any element such as here a, and I will check if is a in the map, it says no, so I will just move forward and include this a, and before moving I will just increase the count of a, so count of a will be increased by 1. Now I am here at b, so is there b in the map? No. I will also take this as add this in our substring, so count of v will be also increased by 1. Next, c is in the substring. No, it's not, so we will just add this also, and we'll increase the count here also. Now moving ahead, now this is the important part. If we are at A and we check in the substring that is there any A in the substring, so yes, we have count of A greater than 1. Count of, if we are here, we will just say that yes, we have found A in the map. Alright, so we cannot add this. So what we have to do, we have to just remove the duplicate characters. But before removing, first of all, we are at here, our substring will become A and count will increase to 2, and we will just check if because at every point we are also counting also, that when A was in the substring, B was in the substring. First of all, A was in the substring, count was, longest substring count was 1, then B was also, then C was also there, then A was there, then A was there, so the count of A was increased to 2. But it means if any count of element is greater than 1, it means we have found a duplicate, so we have to remove that duplicate. So in this case, what we can do, we can just reduce our substring. It's just the normal algorithm of sliding window. What we do here, we, if we find any duplicate, we move ahead, ahead, and if we find any duplicate, we will just shrink until our window contains only unique characters, and we will move ahead till we find till we have unique characters. And if we find any duplicate character, any one duplicate character, we will just shrink until we get a window where we have unique characters. So in this window we have we have got a duplicate. It means we have just got one duplicate, and we have to just shrink the window until we get the window all the elements as unique. So we will just shrink the window. So what we will do, I will just reduce the shrinking the window from backward, and before moving backward, I will reduce the count of the elements which we are deleting from the window. So I will just decrease the count of A now. So here now A, count of A will be reduced to 1. So our window size is now, we can say this, and at every reduction, at every shrinking, we will just check if the count of this A is we will do this until we find until the count of A has become 1. Alright, so by just reducing this, the window size by 1 only, we can see that count of A has become 1. It means now we have got all the window as duplicate, because we will check this element only every time, because coming at this element only we have found a duplicate. It means that this element is repeating anywhere in the window. That's why we will just shrink the window until count of this element has became 1. So now after reducing the window size by 1, we will see that count of A has become 1 now. Now we are very okay. And before moving ahead, we will just update our count also. So size of the current window, that is 3. Now what we do, we move ahead, we are here, so our window is also increased. Now count of B is increased to 2. We will see that now this count has become 2. So what we do, we will just shrink the window, and until we have a count of B equal to 1. So after shrinking the window one time only, we will see that B is now deleted. So we will get this window CAB. So now in our window, the element will be CAB. Cab. Now the count will be increased. What will be the count? Suppose we are here, JI is this. So our count will be the size of this window, and size of this window will be nothing but J minus I plus 1. So we will increase the count. Next, moving ahead, and yes, I will reduce the size also because we have to remove that element. So this will be now 1. Now moving ahead, we have found a C. So now this will be CABC, and this will be count of C will be 2. But before checking the count, we will just shrink our window until we make this count of C equal to 1. So we can see that we can just reduce window by 1 only, and we will get our element as unique, our window having unique elements. So now this has become ABC. We will update the count j minus I plus 1. Again moving ahead, count of B is now increased to 2 again. So we will say that we will shrink the window until the count of B is now 1. So removing this A will reduce this count to 0. Again B, count of B is again 2. Reducing this B, the count of B is reduced to 1 now. So we can say yes, now we have all the unique elements. Count of B has become 1. So now we'll just consider this window CB. Our window will be containing CB. This is just a normal sliding window approach only. We are just shrinking the window whenever we find any duplicate element, and we are just expanding the window every time. So our count will be updated with the maximum count we have found. Current count will be now 2, and maximum count, this I am storing as maximum count. Alright, now moving ahead, we again count will be 2. So we will reduce our window. First of all, we will reduce this C. This count of C was 1, then this will be 0. Again count of B is 2, so we will just remove this B, and now we will see the count of B is now 1. So we can say just we have found a window where all the elements are unique. So our count is j minus I plus 1, that is only one size window. We'll increase our update our max count, this will be 3 only. So we can see here the answer is coming 3. So in the output we can see the answer is 3. So this only we are doing, that whenever we find, what was the example, A B C B B, we were initializing I and j as 0, and I and j pointer were at the starting, and we were just moving j ahead, and whenever until we are getting unique elements, and whenever we see there is a duplicate element, we will just reduce the size of I, we will just shrink the window and move I ahead. So you know, this will take big O of 2n time complexity at max, because j will be moving ahead. Suppose j is something here, and I was suppose here, and now I will be also moving to shrink the window. So at max every element is visiting twice, so time complexity at max is big O of 2n, but we can reduce this time complexity to big O of n by one thing. We can see that our I pointer is moving ahead one by one. If any duplicate element is found, this will move ahead until the count of this j element has become 1. What we can do, we can, if we are able to directly jump this I to something, suppose I was here and some elements are there and j is here. So if the correct position, we were shrinking this window until we set this I to its correct position. So if we are able anyhow to not move I one by one and directly jumping this I to its correct position here, let's say, and then we get our I and j as our correct position. So this is just a sliding window technique where we are shrinking, we are just, when we have to shrink window, we increase our I. But if anyhow, if we not step by step move I, we directly jump I to its correct position, then we will say our j pointer will only cover all the elements, visit elements, and I pointer is is just jumping only, not moving one by one, not using a while loop. All right, so we can say then time complexity will be bigger often. Then how we can do this? We can, instead of storing the count of elements in the map, we can just store the indexes in the map. Suppose this question was there, ABC, BB. We can just take a map and just store the indexes. Let me write down here only ABC, ABC, BB. Suppose there is a map and we store indexes. We are here, I is here now, J is also here. Now we start J, we are here at A, and we found any element in the window. So we found a new element A. Is A in the map? It says no. We'll just move J ahead. We must just move J ahead. And before moving, we will just also make ensure we will just increase our update our maximum count also. And here before moving, I will say that I will add A and I will store the index instead of count. Now B, is there B exists in the map? No. So I will move J, and before moving I will store the index of B as 1. Now C is also there, C is also okay. We will move J and I will store the index of C. Now A is there and we see A exists in the map. A already exists in the map. So what we say, what do? We used to shrink the window I, but in this case, if we shrink the window, I will come here. So instead of moving this I one by one, now we have the indexes. We can directly jump I. So how we can jump I? We can just say jump I to the what we can do? We are here A. So if we find any element A here only, we can just check the index of this element. We have found a duplicate element, so we have to shrink the window. We will just find this index A0 and we will just jump I to this map of value of this A0 plus 1 index. So this will be at 0 plus 1. So we will jump this to 0 plus 1. So now our I pointer will be here. Now we will see that we will get a window which is containing unique elements. So this way we don't have to move I one by one. I will just jump the I pointer to the map of J, that is A, that is 0 here, plus 1, so that we just eliminate this A and we will just get a window size here. Now we will just update our max count also, the size of the window, that is J minus I plus 1. Next I will move here. I will see that yes B exists in the map. So I will say that I have to again shrink the window. So what I will do, I will not just move I pointer ahead. I will just say that now I pointer will be at index of B plus 1. This is 1 and this will be at now 2. So I is jumped to 2, second index. Now I will get here the window with all unique elements. Next C is there. Now we will see that C exists in the map, and yes also that suppose we are jumping I to some element here. Alright, so we are just missing these elements. We have to delete this also. J is here and our windows becoming this now. So if any element comes here, if I will check J is existing in the map or not, we are not erasing these elements from the map. So if these elements are already in the map, this will say that yes, it exists in the map. For so this is the problem. So what we will do, we will just say that check this J exists in the map or not, and if this J exists in the map, then also check that the index of this J element which is already existing in the map should be greater than equal to I, greater than equal to the left pointer. Alright, then only just confirm me that yes, we have any element. So now we are at C. We can see that C exists in the map, and this index number C2 is greater than equal to this left pointer, that is 0 1 2 2. Alright, so okay, we have to just shrink the window, and now window will be shrunk to jump to 2 plus 1, that is 3 index. So third index is this, I is jumped to this. Now we will get a window. Now next, B is B. I should write the index numbers also, 0 1 2 3 4 5 6 7. Now we are here. B, we are at here, index number 6. We have got B. Is B in the window? Yes, B is in the window. But is the index of B is greater than equal to I? I mean is greater than equal to 3, because our current window is this, and B was already B, the window, the map which is storing B is this. So we will just check is the index of B which we have in the map, that is 1, is greater than equal to the left pointer, that is greater than equal to 3. No. So you will say no, we don't actually. Okay, we haven't updated B yet. We are moving elements, but we are not updating. Actually, I forgot to update. So last time C was when this window was there, so C was updated to this 5, and A was also updated to this 3, and B was 4. Alright, so if we find B now, we will say that this 4 is greater than equal to the left pointer, and that is 3. We will say yes, we have this is in our map. So we will now we have in this map, and we will just shrink the window, and this now our I pointer will be at 4 plus 1, that is 5. So I pointer will be here now. This is jump to here. Now our window size is J was here. Window size is J minus I plus 1 2. We will update our max count accordingly. Alright. Now we will update our pointer also. B is here, and we will update as 6. Now again here J is here now at last index. We will just say that is B existing in the map? Yes. And what is the index? That is 6 is greater than equal to I, greater than equal to 5. Yes. So we will just shrink the window, and we will shrink the window to 6 plus 1, that is 5. So I will be jumped to now here. So now the window size is J minus I plus 1, that is 1. So we are getting this window. So now we can see that we have just solved this problem. So this is just a basic normal sliding window technique. Also we can use the version 1 also, expanding the window and shrinking the window, expanding the window and shrinking the window. This will take big O of 2 n time complexity, because I and J pointer are visiting all the elements, and just for optimizing we can just do big O of n also by just moving one pointer J to all the elements, and instead of shrinking I to every element one step by step, I can just directly jump I to its correct position by just storing the indexes in the map. So I will go and implement this. So first of all, I will just check the size of this string, that is s dot size, and we were using an ordered map. This will be storing character, an integer, and I will be storing the maximum I have got. So length of the longest substring, we can say that it's 1, and in the question it's also given that s dot length can be 0. So for being in the safe side, I can just say that if n is equals to 0, we can just return 0, and now iterating all the elements, I will take I as 0 first, and j is also 0, while I is less than n and j is less than n. I will say that if we are at any element, so before updating our max count, we have to shrink the window. We will just jump I to this to its correct position. So I will just say that if s of j exists in the map, I can use count function also. If s of j exists in the map and that s of j, that is our index, is greater than equal to the left pointer, then only we will shrink the window. Then our I will move to s of j. Here I am checking the map of s of j index, so this should be map of s of j, and I will be moved to map of s of j plus 1. Now we have our I and j pointer at its correct position. Now I will say just update our max variable. So this will be nothing but the maximum of j minus I plus 1, that is our window size now. And yes, before moving, we will also update the map of s of j, that is now updated to j. Index will be updated, and j is moving always. So at last we will just return maximum. So if I run this, and let's check if we are able to pass sample test cases, and if I submit this, and let's check if we are able to pass all the test cases. So yes, we have solved this problem successfully now. And if I talk about the time and space complexity, so time complexity is big O of exactly n. We can say that because we are just moving j pointer and every element is visiting once only. We have optimized sliding window. And space complexity for storing an ordered map, this will be big O of n. So this was all about this problem. Thanks for watching. I hope you understood. Till then, keep learning and keep upgrading yourself. See you in the next video.